And before we go to lunch, okay, and the last talk before the lunch is from a big company called Dragos, and the title for this particular talk is actually "Building Defensible Architectures for Critical Infrastructure" by Dr. Jacob Benjamin. Jacob Benjamin is the Director for International Services at the industrial cybersecurity company Dragos. In this role, Dr. Benjamin oversees the delivery and execution of consulting services provided by Dragos for ICS, OT, SCADA networks for EMEA and APAC regions. Jacob has substantial cybersecurity experience with OT at domestic and international critical infrastructures, from his current role as well as his prior role as a cybersecurity researcher at Idaho National Laboratory and nuclear cybersecurity specialist with Duke Energy. Jacob, it's our honor to invite you for this UND Symposium. We appreciate your time here, so the floor is yours.
Thank you. Can you tell me if you can see my slides or if you see like the slides and the notes?
We're good. We're good.
Perfect. Well, thank you so much. That was a great introduction. I really enjoyed the previous talk. I think it's going to go well with my talk as well. So thanks for that wonderful introduction. So we're going to talk about building defensible architectures for critical infrastructure. Oftentimes there's this overlap between IT and what we call OT, or critical infrastructure, the networks that support critical infrastructure. And so there is this overlap between those two, and we're going to talk about that. Okay, 1 second while my clicker works. All right, so when we're talking about building a defensible architecture, I usually like to frame this in the context of the 5 critical controls. These are the 5 critical controls as they were published by the SANS Institute. These controls, I really like these controls because they are outcome focused. They're not prescriptive. There's not 500 of them. If you're looking at other control frameworks such as IEC, or if you're looking at like the 62443 or the NIST controls or NEI 0809 or whatever, and those are all great frameworks. There's just a lot of different controls. So these 5 are really good outcome based control frameworks that you can really use to speak at a high level for executives, and they're outcome focused, and they're really focused on a balanced approach. I heard a couple different times in the previous talk about too much of a focus on prevention and not enough on reaction and things like that. And that is another key message that you'll hear throughout my talk as well. So again, so a defensible architecture is the number 2 in these 5, and you'll see kind of as it goes through. And we'll talk about defensible architecture, and I think oftentimes people will confuse this with secure architecture, and it's just not the case. So when I say defensible, it means a very specific thing. I don't believe there is necessarily a secure architecture. I think it's very difficult it's difficult, if not impossible, to design something as totally secure, right? But we can design something as defensible, meaning that it can be defended, right? And defended by a human defender, right? And so you need a network that works for you. In most cases, people try to start their strategy with hardening the network, removing, access points to the internet or to IT networks, removing high-risk vulnerabilities, things like that. And so, and that's a great start, but that's not necessarily everything when it comes to a defensible architecture. And so there's a lot more of this. So it's more than just people, and it's more than just a prevention focus. It's more than just a wall around your network. Oh, I lost my clicker here. Okay, so I'll talk a little bit about ICS OT security issues before I come back to defensible architecture. So many years ago, ICS OT systems, they were originally developed. Each system was completely different. So a distributed control system at one plant was completely different than a distributed control system at another plant. And so when there were attacks developed for them, they weren't necessarily scalable. And each engineer had to learn how to do things a little differently. I mean, there were similarities, but they were different. And so as things have evolved, we've gotten from systems that were heterogeneous to now systems that are more homogeneous. And then we've also got more and more threat groups that are focused on critical infrastructure. each year we've added additional threat groups, and so that we track here at Dragos. And so there are several ones. Chernovite here is one of the latest ones. Chernovite is one that has the latest malware that we have named Pipe Dream, and this is one that focuses. It's the most sophisticated malware, and it takes advantage of the new homogeneous nature of these control systems, and takes advantage of the protocols themselves, as well as the homogeneous nature of the control systems that we've seen. So it's very scalable. So it's scalable in the sense that the attacks were for, so I'll get through it in a second here. So Xenotime had an attack back in 2017 on a safety system, and it was a very complex attack, but it was not very scalable. It only really worked on that particular system at that particular site. It wasn't easy to replicate. But then, and prior to that, you had Electrum, where, you know, this was the attack in Ukraine in 2016, where it was a scalable attack. It abused the protocols, specifically IEC 101 and IEC 104 and OPC, right? And it abused these protocols to turn off the power, right? So that was a very scalable attack. And then you had the safety system attack that was not very scalable, whereas now in 2023 or 2022, and now I'm still talking about in 2023, we have this attack where it's both scalable and complex. And so that's kind of the state that we're in now, is that we've got these systems where they used to be, each one was very different, and so they were kind of protected in that sense. And now we've got specialized threat groups, and the systems are becoming more and more the same. And so now we've got systems that are more and more the same, with threat groups that are targeting them more. They've understand that these systems are, they're not cost centers like traditional IT. You know, critical infrastructure is the profit center, and so it becomes target for things even like ransomware. So they become more and more targets as well. And the impact for these is significant, which is a completely different impact from traditional IT systems. So back to a little bit about a defensible architecture. And I spoke about this on the previous slide when I mentioned that it was more than just prevention, right? It's more than just network segmentation. So I have some other criteria that it means to be defensible architecture. The first note here is that it does require a human, right? So you want your network architecture to work for you. So, but other criteria for defensible architecture is you need to know what's on your network. So you need to have visibility into the network. So I've got my graphic here. This is from our year in review report that we put out every year. 80% of our customers, we analyzed their networks, and 80% of the OT customers had limited visibility into their OT. And a subset of that had no visibility into the OT. Now, when I say this, this is limited to their OT segments. A lot of them had visibility into their IT segments, and then when you have the break between IT and OT, that's where their visibility stops, right? But then, of course, traditionally, when people think of defensible architecture, they think of hardened assets. So that is a criteria in defensible architecture. Again, people traditionally think of having flows enforced, so firewalls and segmentation. That, of course, is an idea in defensible architecture. This idea of rapid isolation, that's not necessarily something people think about when they're talking about a defensible architecture. We'll talk about that in a little bit. I'm talking about rapid collapsibility, the idea to kind of do a cyber load shed, and we'll talk about that in a little bit. And then this idea that it's defended, that your architecture is well understood, that you understand the impacts of different pieces, and that you know, everything is understood and it's defended. And so we'll talk about that in a little bit. So again, so a couple of pieces about this as well. Asset visibility is a part of that overall visibility. And the best way to start with that is with assets. So you do have to understand your assets that are on there. So that's essential. To do any kind of protection of your network, you have to understand what's on there. And you have to have a sufficient detail so that you can correlate that to different threats and especially vulnerabilities. And it's not enough just to understand what's on your network, specifically in critical infrastructure, right? So we're using different protocols. So critical infrastructure is going to have different device types, different protocols, different impacts, different missions. We have different everything. And one of the things that we have is different protocols. And so you need to have Your network visibility needs to be able to dissect those protocols and understand that what's going across. It's not enough to be able to say, well, I see that there's a DMP3 communication between these two devices. We need to be able to see, well, is it sending a command? What command is it sending? You know, what is actually happening? Can we dissect that protocol? Right. So understanding what's happening there from that standpoint is critical to understanding it. And so all of these things lead to faster threat detection. And so again, we like to map it to TTPs as well as to MITRE ATT&CK. We use a specific branch of MITRE ATT&CK. We prefer the attack for ICS as it's closer to the impacts that are more aligned to traditional critical infrastructure. But of course, you're going to map any kind of campaign across both stage 1 and stage 2 of the ICS kill chain. Stage 1 being closer to traditional IT attacks, and stage 2 traditional, or not traditional, but critical infrastructure style attacks. You're going to see kind of both there, and you're going to map it where it makes sense, right? And so obviously adversaries, as the previous speaker mentioned, right, they're going to modify their attacks. And so we need to have detections that make sense and that are not just IOCs, right? And so we have to have a couple different kinds of detection. So we don't rely simply on just on IOCs or hashes or things like that. And so we work on anomalies. So we've got baseline detection. So what normal traffic looks like. We also have behavior-based detections, but not just like baseline, but behavior based on threat analytics. So intelligence-based threat behavior analysis. And then we also have, you know, IOCs and things like that as well. So combining these things with different things. So a mixture of AI and actual intelligence and threat intelligence all together, right? And the idea here is to detect these things earlier and earlier on in the attack kill chain so that we can prevent things prior to the impact happening. And so incident response is a very expensive endeavor. No matter like when it happens, it's very rare that it's a cheap thing. And so the earlier we can detect it, the better. And one of the most important things is understanding what to do when that happens. And so the worst time to test your incident response plan is during an incident. And so it's great to have your incident response plan and to test it ahead of time with the tabletop exercise, things like that. But it's also great to have playbooks installed for specific things. So one of the great things that we like to do is we have our TTPs mapped out and we have our detections mapped out for these specific things, and then playbooks what to do when we detect these specific things. What are things that we can do for it? This is all part of having a defensible architecture, is understanding what to do when you see specific things happening, right? To train your security operations for what to do when they see certain detections and things like that. All because, you know, time is very important when you see these different detections. So one of the things that we talk about when we're doing a defensible architecture is this idea that vulnerability management. So there were over 2,400 ICS or OT specific vulnerabilities that came out in 2022. And so patching is very difficult in OT. And in most cases, it's impossible to patch, let alone patch all of those. And so we analyze, our threat intelligence teams will analyze all of those vulnerabilities that come out. We'll look at all the different feeds as well as redouble check them on our end as well. And we found that only about 2% actually need immediate action. They fall into this now category of now, next, never, of what we need to do. Never is not necessarily never in that you don't ever have to do anything. Never might be, you know, way down the road. Perhaps you just, you know, it's going to be a low possibility. I'm a nuclear person. That's my background. So never might be, you know, a couple outages from now, right? And so one of the advantages of a defensible architecture is I'm able to do a risk-based vulnerability management. I don't have to patch every single thing because I can only focus on the ones that are super critical because I've got an architecture I can rely on, you know, defense in depth that I can rely on, that I can then only worry about the ones that are really important. And so that's super critical, right? Now being the ones that I specifically have to do. And again, the answer might not be patch. The answer might be, you know, firewall rule updates or, The answer might be additional monitoring or something like that. You know, the answer doesn't have to be patch, which again is very difficult in OT situations. So more towards traditional defensible architectures, it usually comes down to segmentation and flow enforcement. And so again, kind of what the previous speaker was talking about, this idea that prevention is not, it's ideal, but it's not guaranteed. And so we have to understand that, you know, this idea that you can't always do what's been done. Like, so yeah, you can detect what's previously been discovered, but you know, you have to understand that the bad guys are going to overcome that, right? And so not only are they going to overcome that, but our prevention measures that we've put in place, they're going to atrophy over time. And so I've got a graph here of the NIST cybersecurity functions, the 5 functions that we have here. And I've categorized them as prevention and active. So preventative and active. And so I did some analysis on a blog, I think a couple of years ago at this point, where I looked at the controls for this and I thought, you know, I expected all the different controls in the NIST framework, I expected them to be kind of evenly spread out across those 5 functions, because those are the 5 functions of the NIST framework. I thought, well, they'd probably be roughly 20% each function, but it actually turned out in most cases, they fell into that preventative category, where in most cases, over 80% of the controls fell into the identify and the protect category. And very few of the controls were left for the other 3 active ones. What do you do if somebody gets past those barriers and you're stuck in the active, or you're stuck in the detect, respond, and recover categories? There were very few controls. And so what was happening is asset owners were dumping all of their resources and all of their money into the identify and protect. And then if somebody was to bypass that, they didn't have necessarily the resources and the training, the things to build up that capabilities for responding and recovering, right? Which we advocate almost the other way around, where you need to assume a breach or assume that something bad is going to happen and worry about responding and recovering first. And this feeds into this idea of understanding your network, right? And then prioritizing those. That's why I have the crown jewel thing here. Let's see. Let me go here. So typically people talk about segmentation of their network. Yes, this makes sense. Usually people do the Purdue model here, where you've kind of got, you know, the 5 levels, and it's broken down with IT down to the OT, and that works great. I like to think of it upside down, which is why there's nothing wrong with your screen. I have flipped it completely upside down. So I've got my OT devices up at the top. I just think of it that way because that's the critical things that I like to think of. And so I've broken it out, zones within my level. I like to think of it zone defense. I am a football fan. I sort of think of it that way, right? And so I've got my safety zone. I make sure I'm completely zones within those levels, kind of broken out, like micro segmentation between those, right? So I've broken those out between them. So it's important that you have segmentation, but it's like you need to do additional segmentation within those as well. Now, this is a topic that I really wanted to talk about here because I feel like this doesn't get enough traction. People talk about segmentation and micro-segmentation all the time, but they don't necessarily talk about this idea of collapsible infrastructure. And so this is the key part of a defensible architecture in my mind, is this idea of rapid isolation, the ability to go into a defensible cyber position when something has happened. When you're in a critical scenario, such as something you've identified in your incident response plan, whether it's, whether it's a ransomware scenario or an APT attack or something, this idea that how quickly can you cut all non-local connections? How quickly can you apply a new firewall rule? If you're a critical operation, maybe you're a nuclear plant or maybe a petrochemical company or something, how quickly can you rely on analog means instead of digital means for safety related decisions? Like that kind of situation, how can you quickly collapse your cyber load shed? Like how quickly can you load shed anything cybersecurity related? And that's a really interesting idea, like to help stop spread of ransomware, and then, not just ransomware, but anything else really too. And so also, as we briefly move on here, we can go this idea that I talked about, making sure that we move from being defensible to being defended. And so making sure we understand our network. This is a problem I see a lot in our assessments of critical infrastructure, is we've got really complex system of systems networks. They're very difficult to understand. Oftentimes, people will understand one piece of it, and maybe only one or two people on site will understand everything overall. And so it's really important that we document normal range of set points. What are the communication protocols there? What are the sources of approved logic changes? Can anyone push logic changes? Can any of these devices, or is it just these 3 devices? And then maybe we put up detections and alerts for anything that's pushing logic changes that isn't these 3 devices, right? And then I've got a crown jewel analysis graphic here. This is our idea of doing critical system analysis here, right? And so just having a better understanding of our network and our process, and not just from a cyber standpoint, but understanding the process itself and what are the impacts that we could possibly have. And continuing that idea of understanding what we're doing is this idea of a collection management framework. And so this is a dossier of information of where you can go to get information. It's almost like a little, it's not a little notebook. Hopefully it's like some kind of like a matrix of note. It's a collection of information of where to go get information. And it might make more sense when I click to the next slide and you can kind of see a deliverable for it. And so what happens is, say you have an incident and you need to answer a question, but you don't know where the answers to those questions exist. A collection management framework, this idea comes from the intelligence background, this idea of where you can answer those questions. And so we use this a lot with like the SolarWinds breach when we wanted to answer, okay, have we been compromised by SolarWinds? We know we have it in there, but how do we answer those questions of whether it was actually exploited or not in our network? Well, we need to go look at the logs. Well, where do those logs live and how long do we have them for? Being able to answer those questions easily without where do those boxes live and who has control of them and what are the next steps from there. So just having a single place to look for that information is super valuable, right? And so here's just like an example of a CMF. It's like, okay, if I want to look at firewall logs, okay, I've got 12 months worth of those. Where an example might be, well, maybe I needed 6 months worth of logs to answer my question, but I went and looked at my CMF and I see that I only have 3 months worth of logs. I don't need to spend a bunch of time going and pulling that log because I know I can't answer that question. And so I can move on to something else critical in my investigation, because remember, time is very valuable when I'm doing an incident response case, and I don't want to spend a bunch of time finding information only to find that information is not going to be valuable to me in the end. So having this kind of collection management framework, a centralized location of where I can go to answer the questions I'm going to need, is super valuable in an incident and can save me a bunch of time. And so that's a key part of understanding your infrastructure and making sure that like anybody, you can ramp up anybody to help you during an incident. And so kind of back to the 5 critical controls here. Typically when people think of an infrastructure, defensible infrastructure, they think of it by itself. What we like to do is we start with the incident response, and it needs to be ICS specific. You need to understand what you're trying to defend against. So you're taking specific scenarios that have been seen in the wild and using that to make sure that, can I defend against those? So what's relevant to my sector? So if I'm in water, then I need to make sure I can defend against scenarios that have been seen in the water sector, whether that's, OSMAR or something else. If I'm the electric sector, I need to know that I can defend against things like Ukraine events that have been happening. Or if I'm in the gas industry, I need to make sure I can defend against, obviously, like ransomware and Trisis and things like that, right? So my incident response plan is going to inform my infrastructure, right? And so I need to have the visibility and monitoring to make sure that my architecture is still in place and it's still valid, right? So I need to have constant monitoring of the network to make sure that it's still in place and that it's still effective. And then obviously, an architecture it's not really helping me if it doesn't allow me to have secure remote access, right? If there's insecure remote access happening, then I need to make sure that then it's not actually defensible, right? And then obviously I need to be monitoring any kind of remote access that's happening. A defensible architecture allows me to do a risk-based vulnerability management instead of having to patch everything. And again, so you can just see how these 5 controls sort of drive. So the first one drives the scenarios I need to protect against, and then it kind of builds out the rest of them out there for me, but they all kind of circle and help each other out. So in general here, defenders must assume that the architecture will never be fully secure, and we have to focus on building it out. So the key points that I'd like to take away here is that a defensible architecture is going to, at first, prevent as much cyber risk as possible. But the most important thing is it has to help a human defender. Like I know there's a big push for AI, and I want to use AI as a tool, but we have, like, one of the things with artificial intelligence is it doesn't always provide the context needed to, it'll tell you there's a problem and there's alert, but it doesn't always tell you the context behind that alert. And that's really important. We need to understand why that decision was made or why that classification was made, so that we can better understand those things. So we need our network architecture to work for us, not necessarily against us or to be unclear. So we need to, so that bullet about being understood, we need our architecture to be well understood by us. So yes, AI is going to be a tool, but we also need to make sure that we are still in the loop, especially when it comes to critical infrastructure. Of course, we have to have full visibility. We can't protect what we don't know we have. And of course, when it comes to anything, when it comes to traditional network architecture, it's got to be hardened, it's got to be segmented, the flows have to be enforced. That's all standard stuff. Collapsible, that might be something maybe you haven't heard before, this idea of a rapid collapsible infrastructure. I've seen some technical implementations of that with software-defined networking and some really interesting ways of actually implementing that. I think that's really cool and some really things that we could do in that mindset, but that would be a way that could be really a way that facilitates the human defender and our standpoint. And so I wanted to start to wrap up by posing some future research and open challenges, and then definitely leave some time for questions. And so some of the future research challenges I had is that I want to have this quote that came from Idaho National Laboratory, which is, the industry has been working to assess adversary capabilities through a keyhole rather than a deeper collection and broader field of vision. And so this quote came about talking about Neighborhood Keeper, which is a product Dragos makes about machine speed threat intelligence sharing. And it's how we share threat intelligence, again, at machine speed. So it's not just sticks information sharing and then, like, you know, you upload it and then it has to get processed, and then, like, it's machine to machine. Like, have you seen this threat? Have you seen this or have you seen this vulnerability, and that kind of stuff? Like, it's machine to machine speed, something that can help prevent things. And I think that's the future of being able to share things at that speed instead of this. That's one of the key challenges I see for critical infrastructure and the world at large, is how can we more quickly share threat intelligence? And I think that's a key future. Another key research challenge I have here is this idea of classifying process anomalies versus cyber attacks. This is something that I remember seeing a bunch of times on RFPs and things like that. And it's still a challenge now, is this idea of how do you differentiate between just normal engineering process anomalies and cyber attacks? It's still very difficult. I think this is a great way of diving in. This is still an applicable area of interest. Incident response collection tools is still interesting area for OT. Again, like I said, there's different devices. You can't always use the same tools that IT uses. There are differences, and they have to be vetted and things like that. And so there is an area there to keep doing that. There is a big push for zero trust capabilities. Zero trust right now in its current state kind of goes against everything that there is for OT. Like, OT works on this idea of inherent trust. Like, zero trust and OT are incompatible at the current moment. And so until we can get the risk reduction of zero trust, like, until we can get that down to an acceptable level where we can implement something like zero trust and OT without putting operations at risk, then maybe we can start seeing that being implemented in OT. But right now the risk is too high for that, right? With latency issues and things like that, that would impact operations. So those are I think the key areas that I would see future research and open challenges. And with that, I've got just some further reading for people to do. And I wanted to leave a couple minutes for questions, and I think I have.
Thank you, Dr. Jacob, for I think a short and nice, and I think I really loved your the last slide as well. I think open, being a research center, we are trying to looking at open-ended research problems, so it's very insightful. Any questions for Dr. Jacob? Let's open up for a question. Yes, we have Andrew who has a question from Waterfall. Students, I encourage you to think about questions for OT. So this is a great opportunity to interact.
Hello, Jacob. It's Andrew Ginter from Waterfall Security. Thank you for the presentation. A question. You identified, the incident response as a critical, in a sense, underserved need in industrial systems. Yet, in my experience, and I'm not an incident responder, so correct me if my experience, incident responders need to be, well, bluntly, heroes. They have to know almost everything. Finding heroes is hard. Retaining them in a smaller organization that doesn't have many incidents in the year is almost impossible. Given that we need incident response capabilities in most organizations, and that it's impossible for most organizations to retain these people, much less, if they can even find them. How do they do this? How can we achieve this apparently impossible goal?
That's a great question. Thank you, Andrew. And it's great to see you again. Even though I don't see you, I've seen you before. It's great to hear from you again. I don't know. I wonder if the MSSP approach might be the way to go. I mean, it's very difficult, right? Like this idea of, using retainers for incident response. And I don't just say that because we have an incident retainer business, right? Like we sell incident response retainers, but so do other people, right? There's lots of incident response retainers, but it's so specific. It might not be a skill set that every asset owner might not need, right? Like, does every asset owner need a reverse engineer? Like, I'm not sure that's the right answer, right? Like that might be something that you just get on retainer and do, because that is a very specific skill set. Now, what I would say is you need to be prepared for that, right? So every asset owner should have something like, they should understand their architecture well enough that when an incident responder comes to on site, they can be handed the documentation they need to very quickly help them up. And I have seen it work really well where corporations, and again, this is more for bigger corporations, where they have like a corporate team that oversees like 20 more sites, right? And they get flown in, right? And they kind of get bubble up. But for the small team, I'm not sure there's a right answer other than hopefully like a retainer kind of program. I think it's very difficult to retain that kind of talent and to map the necessary skills that you would need. That's a great question, though.
Great. Any questions? Any more questions? Yes, one more.
Hi. I was wondering, how often do you integrate real space securities into this, such as air gapping certain control units?
All the time. You talking about just like air gapping things into like visibility, like we've partnered with Waterfall before with Andrew's team, like all the time.
Jacob, could you talk more about the cyber load shedding? I know you talked about 4 steps, but how does Drago is planning to handle that? Or can you insight in terms of or do we always have to be reactive in terms of this? And how do we? I'm just curious to see. Could you please talk more about the cyber load shedding? That seems interesting to me.
Yeah, it's more of a plan. It's more of a plan, and it's not something necessarily that Dragos would do. It's more of like a plan, and it's idea that I got talking with Tim Conway from the SANS Institute. Like we were talking about this idea. We're just talking about load shed when we were talking to cyber electric system operators, and we're talking about this idea of load shedding that you do in operations, right? When you need to, like, okay, I can't have this much load, right? Like what I need just the critical loads. Like what can we do when we're in a critical cyber event? Like what do we need? Like how quickly can we do these things, and how quickly can we disconnect that kind of stuff? And so having this idea of like, well, if I need to replace all my firewalls, can I even do that? Like if there's a vulnerability if there's a vulnerability for the firewall at my site, can I replace everything, or is every single firewall in my warehouse exactly the same? And if I replace it, it's the exact same vulnerability. Like, am I really stopping the defender at all, right? Do I have any, I guess the word I'm looking for is, do I have any resiliency, or do I just have redundancy? I think that's the question. It's like, so baking in this idea of resiliency and making sure that I don't have just the same switches and the same firewalls. And I'm not saying you need to go and buy one of every vendor or anything like that. I think that's crazy too. But just this idea of being prepared for minimal cyber operations and getting to like a heightened state, right? Does that help? And I think it's something that's
Yes.
going to be different for each asset owner. I don't think it's something, and it's going to be specific to you and your site. Yeah.
I'm going to ask you one more question. We have a lot of students here, high school students, undergrad, graduate students. So what do you advise in terms of for their considering cybersecurity field? What kind of advice do you guys have from an OT point of view or in general?
From the OT, I would say, make friends with engineers. Like, I feel like they're merging fields. Like, so when I was in college, I couldn't decide if I wanted to be an engineer or if I wanted to be a programmer. Like, I literally couldn't decide. And there's a program at my school, and it was like you could do both. Like, you could do a joint thing, and then 2 years later, whatever. And I chose programming. And then after I graduated, I ended up working at a power plant anyway. And so it didn't matter. Like the fields have just kind of come together. And so I think but there is still this idea of sometimes we're not speaking the same language when we're talking to engineers, when we're talking to cybersecurity personnel. And so there is this lexicon difference. And I think MITRE ATT&CK is helping, like speaking the same language when we're talking about this, especially having the ICS one. But I think this idea that making sure that we're speaking the same language when we're talking about impacts and operations and engineering, I think there is this, I'm not saying IT-OT convergence. I do think that's something that already happened, but this idea of engineering convergence, I think people are going to have to be mechanical engineers, electrical engineers, everybody's going to be a cybersecurity person, right? Even a mechanical engineer, civil engineer. So I think maybe making sure that we can help speak that language or bridge those gaps. I think everybody's going to be cyber. So even kind of similar to how those some of those old science like chemistry people would come up and they want to learn like COBOL programming language from like a long time ago, right? They come ask you like questions of how to program. I think you're going to get like random people asking you how to do things like how to code different things in AI. Like, right? I think you're just going to get that from all areas now. People are going to be super curious about cybersecurity. So I think just make friends and see what kind of problems you can solve by joining forces with other disciplines. I'm a big fan of cross-disciplinary problem solving.
Fantastic. Thank you so much, Dr. Jacob, for your time today at UND. And you will receive a plaque in the contribution of your time. Thank you so much again.
Thank you. I wish I could have been there in person. I just wanted to see the kids trick or treat,